Hi guys, today we're going to talk about how to write quadratic functions if we are given different pieces of information, and we'll see how the different forms of quadratic functions that we have, standard form and intercept form and vertex form, are useful in different situations. So to start out with, do you remember what standard form looks like? Yeah, that's where you will see y equals ax squared plus bx plus c. So that's what we call a standard form for a quadratic equation that will graph a parabola. Intercept form is the form that helps us see the intercepts easily. That's where you have y equals a times the quantity x minus p times the quantity x minus q. So when it's in this factored form, where your x's have just single coefficients, your a is pulled out front, the p and the q are what will give us our x-intercepts, also known as zeros, also known as roots, also known as solutions. And then vertex form is the third form we have learned, and that is where it looks like y equals a times the quantity x minus h squared plus k. And that's where the point hk would be the vertex of the parabola. And this form looks most familiar to you because it's also what we talked about when we did transformations, where you take something and slide to the left or slide to the right or up, down, stretch it, whatever. So that's why that one looks familiar to you. So let's see how we can use these to write equations here. So for our first case, I want us to write the quadratic function for the parabola that has its vertex at 4, -1 and passes through the point 8, 3. So first of all, we know the vertex. The vertex is at 4, -1. So if we know the vertex, what form do you think might be helpful here? Yeah, vertex form. Okay, so we're going to use vertex form here. So I'm going to write that down first. So y equals a times the quantity x minus h squared plus k. You use the form of the quadratic function that's going to be most helpful to you. Now, if they give the answer in a different form, fine. We will cross that bridge when we come to it. But you choose the form that you would find most useful in this situation. Okay, so don't worry about how the answers look if you have something that's multiple choice or something until the very last thing. We know the vertex, we're using vertex form. So that vertex, that 4, -1, how is that going to fit into this thing? So how do we label the vertex? That would be h and k. So let me label these. So h and k. So that means the 4 is going to go here for my h, and the k, or the -1, is going to go back here for my k. So I'll go ahead and fill those in. So we have y equals a times the quantity x minus 4 squared, quantity squared, and then that k is the -1. So I'm going to, I was going to do that. 4 in purple. So that's what we have so far. So we almost have the quadratic function written for this. The only thing is we're supposed to have a number in place of a. A is not standing for a variable here. Our variables are x and y, but we don't know the a value here. So that's a problem. We need to figure out what that is. So what other information do they tell us about this parabola? Well, they do mention that it goes through the point 8, 3. Okay, so that's a point. 8, 3, we know that that point is on this parabola. And a point is always an ordered pair that we label as x and y. So let me label that 8, 3 with an x and a y. But we're trying to figure out what a is right now. We want to have a number for a. So what we're going to do is we're going to use that xy pair temporarily in the equation, just temporarily, so that we can figure out what the a value is. So let me show you what that's going to look like here. So this y over here, that y, is what I'm going to replace with the 3 equals, I don't know the a value yet, x minus 4 quantity squared. Oops, I forgot to do something. That x I was supposed to replace with the 8. So the x is where I'm going to put that 8. Okay, so this has all numbers except for the a. So that means this is an equation that I can solve to figure out what the a is. So let's work on doing that. So I see the parentheses need simplified. So 8 minus 4 inside of there, that would be 4. And then that's getting squared. So I'm going to write that as a 16. So we have 16 from all of this. That gives me my 16. Now that 16 is getting multiplied by a. So now, okay, the way that it's written, the a is on the front end, but that looks real weird to me to write a times 16 instead of 16 times a. So would it be okay with you if I just use the commutative property right there and put the a on the back of that 16? I think I would feel better about it. So let me put that 16 in front of the a. Let me bring down the minus 1 and bring down the equal sign and bring down the 3. Okay, so we need to solve this equation. So our a is multiplied by 16 and then it's subtracted by 1. So if you're going to solve that, we got to get rid of the minus 1. How do you get rid of minus 1? You add 1. So I'm going to add 1 on both sides of this equation. So we will have 4 equals 16a. And then we need to divide by 16 to get the a by itself. The 16 cancel, 16s cancel. So a is the fraction 4/16, which reduces to 1/4. Okay, so we know what a is. Now, remember our goal here. We are trying to write the equation for this function. So, and we're writing it in vertex form right now. So we need to fill in the a and the h and the k. So let me go back to what quadratic or vertex form is. Y equals a times the quantity x minus h, quantity squared plus k. And we have known our h and k value since the beginning. The h is the 4 and the k is the -1. So I'm going to put the 4 back in here for the h, the -1 back in here for the k, and this a that we just figured out is going to go right here in place of the a in the equation. So now notice I didn't keep that 8-3 ordered pair because there are lots of points on this parabola, or I should go this way because it's a smile. There's lots of points on it. There's actually an infinite number of points if you think about a parabola as being like a whole lot of dots all lined up. 8-3 is only one of those dots. So I'm trying to describe the entire parabola here. So I want the x and y variables to be in place. I only used that 8-3 pair temporarily so I could figure out what that a value was. So now that I know it, I have the equation for my function. So let me prove to you that that is right. I happen to have it graphed over here on Desmos for you already. So I have it typed in. That's the red parabola that you are seeing. And remember how it said the vertex was at 4, -1? Well, let me just click down here at this vertex for you. Whoa, look at that. It's at 4, -1. And it said that this was supposed to go through the point 8-3. So, oh, and look at that. There's the point 8-3 right there on the parabola. So we're right. So there is one thing that we can do with this. Now let's look at a second case. So what if we want to write a quadratic function for the parabola that has x-intercepts of 9 and 1, and it also passes through the point 0, -18. So we have different information this time. I don't know where the vertex is this time, but I do know where the x-intercepts are. We know where the x-intercepts are. I wonder what form of the equation we should use. No, not standard form. We know where the x-intercepts are. No, I wouldn't use vertex form. Yes, intercept form. You're so good. Okay, so intercept form here. Well, intercept form is always y equals a times the quantity x minus 8. Oh, I messed up. X minus p and